Hello everyone, today let's solve the problem number 146 LRU cache, least recent used cache, right? So what the question states here, we have to design the data structure LRU cache. As I mentioned, this one, the abbreviation is least recent used cache, right? So here in this case, we have to design the data structure LRU cache, right? So with a fixed capacity. So with the fixed capacity, we have get and put. We have get and put, which consists of the this one parameter key. Get consists of the parameter key and the put consists of the parameter key as well as the value, right? So here we have get and put, where get, in the get we have to return the value if it exists, else -1. We have to return this one value if the key exists, or else we have to return -1. If the key exists, then we have to return the value, or else we have to return -1. In the put, we have both key and value as the parameters, right? So we have to add or update key. We have to here this one. By looking at it, we have to know, right? We have to add, what happened to this one mouse? We have to add or update key here. Update key. So I'll just give update key here. So in the put. So here what we need to do, get. So we have to get the key. We have to get the value based on the key. We have to get the value based on the key, from the key, or if the this one key doesn't exist, then we have to give -1, then we have to return -1. Just keep this in mind, get and put, right? So both get and put must run in big O of 1 time. So they have strictly mentioned that both get and put must run in big O of 1. So time, so the time complexity has to be big O of 1. So just keep this in mind. So we will be making use of the linked list for this. So we are done with the question part. So you know now, you understand the question. We know the question part now. So here now let's do one thing. Let's go with the approach followed by the complexities, and then let's write the code for the approach part. So before discussing the approach part, I just want to say one thing. So here we will be making use of the linked list approach. So the operations that are provided by the linked list, the operations that are provided by the linked list. So we'll be making use of the linked list to solve this particular problem, right? So just keep this in mind. So let's come to the approach part. Let's consider the first example, same thing here. So let's discuss this one. Let's consider this one for discussing the approach. It will be means we can understand this one clearly, right? So they have given only one example for this particular question. Let's discuss the example one. Let's consider this one for the approach, right? So then let's this one. Let's do one thing. Let's discuss the complexities and then let's write the code. First one, let's go with the approach first. So here for the input we have this one. So one thing I want to tell you here is, so both these things, what do we call, put and LRU cache, this one is nothing but the initialization part, and this one put actually we just have to insert the value, right? So we have to insert the value and the key. So we have to insert the value and the key. Basically we have to add, means insert, or we have to update the key. That's what we need to do in the this one, what do we call, put. So we don't have to return anything over here. So here for the put and for the initialization part, nothing but the LRU cache here, the this one return value will be null. For both these things, the return value will be null. Just remember this one. So for the get, return value will be integer. For the get, return value will be integer, right? So only for the get, return value will be integer. For other two things, for the initialization part, the return value is null. For the put also, this one, what do we call, return value is null. So let me come here. Let's consider this one, LRU cache of 2 we have. So this is the initialization part. Quite obviously we have to get the output null. We have to get the output null. So first what we have done, so we will go with the initialization LRU with the capacity 2. So we will be going with the LRU cache with the capacity 2, right? So here on this case, let's consider here, just for the sake of this thing, we are going with the capacity 2, right? So here now we have capacity 2. Now we have the capacity 2 here, right? So now next what we have, the return value is null, so we will output null itself. So next we have put of 1 comma 1, put of 1 comma 1, right? So now we will be making use of the this one, as we are going with the key value pair, as we want to go with the key value pair, we'll be making use of the hash map. right? So we can make use of the hash map. It will be very handy basically, right? So now we will be going with the put of 1 comma 1. Put of 1 comma 1 means the key will be 1 and the value will be 1. So and again the return value will be null itself. The return value of put is null, only the return value of the get is integer. So this one, let's go with the put again. Put of 2 comma 2. So now this will be, we'll add one more thing here. This will be 2 equals 2 2 2. So I have to add this one and the this one, what do we call, same this thing, flower bracket, but I'm going to do this differently. You can just include this one within the same hash map, so you don't have to go with different brackets within the same hash map, right? So let's go with a get operation. Now we have get of 1 here. So this previous one return value is null, so we have to get the value 1. We have to get means we have to get the value based on the key. So this is the key, this is the key. So this returns 1 because 1, the key 1 consists of the value 1. So this is key, this is value, right? So the key 1 consists of the value 1. So we will return this one. We'll return the value, nothing but here when we get the key 1, we'll get the value 1. We need to return 1. So I hope the this part is clear. Next we have to go with put of 3 comma 3. Again the return value will be null, so we have to add or insert the key 3 and the value 3 to the hash map. This is fine. I hope this is fine. Now we have 1 1 2 2 3 3. Next this is null, output is null. Then we have get of 2. Get of 2 means this one. So this is key, so we have to get the value based on the key, right? So this is key, this is value. We have to get the this one, key 2. Key 2 is having the value 2, so the output will be here. So we have get of 2 right here. Just give me a second. So yeah, here I got confused, man, sorry. So what happened here is we tried to in the last step we went with a put operation, right? So put of 3 comma 3, right? So we will not be able to go with this one. We will not be able to go with this one because we have only two space, right? So here this one LRU cache, we are having only this one. We have initialized the LRU with the capacity 2. This one capacity is already 2, this is not 3. So what we will do, recently used cache among 1 comma 1 and 2 comma 2 is 2 comma 2 recently used. This one we will delete. Basically we will delete this one and we will add 3 3. We'll add 3 3 now. This consists of basically hash map consists of 1 comma 1 and 3 comma 3. So I got confused here, sorry, in the last step. So it would be 1 1 and 3 3, right? So we don't have to recently used was 2, not 1. First we used 1, then 2, right? So recently used was 2. 2, the key and the value 2, I'm speaking of this one. So this one we will delete. So now we have 1 1 3 3 in the hash map. So we are trying to get the key 2. So that doesn't exist in the hash map at all. That doesn't exist in the hash map at all. So the output that we need to return here is -1. So the output that we need to return here is -1. I hope this part is clear. Sorry, I got confused in the last step, this one, right? So next let's go with the put operation. Put of 4 comma 4. Put of 4 comma 4. So here in this case recently used was this, what do we call, so recently used was 1 here. We recently used was 1. We have put of 4 comma 4 and the recently used this one cache is 1 comma this one 1 1, right, with the key and the value 1. So this one we will delete this time. This one we will completely delete this time. Now what we have to add this one 4 4, right? The hash map consists of now this one 4 4 as well as this one 3 3 is still there, right? So this one consists of 3 and 3. So this is fine, right? So this one is 3 3. This is fine. Now we are done with the put operation, right? So we are done with the put operation. Next let's go with the get of 1. So get of 1. So here 1 again, 1 doesn't exist at all here. So before getting into the get operation, so here this one put of 4 comma 4 again, the return value of the put is anyways null. Now we have 4, the value key 4 and the value 4 and the key 3 and the value 3. So now we are going with the get of 1. 1 doesn't exist in the hash map at all, so we need to return -1 here in this case, right? So if the key doesn't exist, then we have to return -1, right? So that's what they have given in the question. Next we are left with get, two more get operations. Get of 3 we have, this is key, this is value. So we need to get the value of the, this one, we need to get the value of the key 3, key 3, right? So here we need to return 3, so we have the value 3 for the key 3, so we need to return this one, we'll get the output 3. The final part is we are left with get operation, last one, get of this one 4. Yeah, we have 4 here. So here key, based on the key we will get the value 4, we will get the value 4. So this one will be, we will return 4, will return 4. This is how we got the output, man. So this is how we will be making use of the hash map along with the linked list basically, right? So here the output that we got here is 3 times null, 1 null, -1 null, -1 3 4, right? So we will be making use of hash map and the linked list data structure, the operations of the linked list, basically hash map and the linked list, right? So just remember this one, linked list along with the hash map. So we are done with the approach part. Let's quickly discuss the complexities. We know that they have asked in the question to design this one. What do we call the methods get and put within the big of one time, right? So the time complexity would be big of one. The time complexity would be, I mean the time complexity for the operations get and put would be big of one here, right? Because for both get and put, we are making use of the hash map and linked list operations as we have discussed, right? So it will lead to this one because of one time complexity. And what will be the space complexity here? The space complexity would be because of capacity. The space complexity would be because of capacity, right? So here in this case our initial capacity is 2. So we have been asked to initialization, I mean in the initialization we went with the LRU cache of 2, right? So the, this one, the space complexity would be because of the capacity, right? So the space complexity would be because of capacity and the time complexity would be because of one for the code that we'll be writing in the future. I hope the complexities part is completely clear. Next, let's do one thing, let's discuss the let's start writing the code. As we are completely familiar with the approach and complexities, let's start writing the code. So let's go with the initially let's go with the node class for the doubly linked list. We will be making use of the doubly linked list, right? So I want to tell you one more thing, that we need hash map for big of one key access, and we will not be going with a single linked list for this. We'll be going with a doubly linked list because we have to track the usage order. We have to track the usage order, right? Based on that itself, we have to remove. We have to remove here in this case. If the capacity exceeds, then we have to remove by making use of the put operation, right? So that's what. Remove the most recently used. Remove the most recently used. So in that case we'll be making use of the doubly linked list. On get or put nodes are moved to the front basically, and when the link, this one is full, capacity is full, the recently used node will be evicted. The recently used node at the tail will be evicted. So now as we have the complete idea, let's start writing the code, right? So first let's go with the class node here, right? So we'll be going with the node class for doubly linked list. So I'll just go with class node. So this is fine. Within the node class, what we'll do, let's go with key and the value. Let's initialize key and value. So here node previous, next, this is fine. So node of, so int k, this will be int v, this is fine. So within this one, let's go with the initialization. Let me initialize key to k and also value to v, value to, this is fine. I'll just come out of this one entirely, right? So now let's go with the max size of the cache, nothing but here in this case private in capacity. So we are going with the capacity, nothing but capacity is nothing but here the max size of the cache. Next, after going with the max size of the cache, let's go with the key, means we have to go with the node map for big of one access accordingly with the question, right? So I'll just write here private map. So within the map, so we are making use of the integer here, this is fine. integer comma node. So here let me make this one capital I, and also miss anything. Why this is not capital I here? So let me remove this one and let me close this one here. So this is fine. Let me make use of the variable name map here. Hope this part is clear. The next thing is, let's make use of the dummy head and tail for the LRU linked list, right? So dummy head or tail will be usually useful for most of the linked list problems. Basically dummy node, we can call that one dummy head node. Here in this case we'll be making use of dummy head and tail for the LRU linked list. So I'll just go with private node. This will be head comma tail. This will be head comma tail. So this is fine. Let's go with the initialization part within the LRU cache. So let me initialize capacity, start capacity by making use of this keyword here, capacity. This is fine, and let's assign map to new hash map. This is fine. So we are done with the initialization part. Next, let's move on with the get. Let's move on with the get method here, right? So here, so we have to initialize the dummy head and tail as well, right? So I completely forgot this one. So let me do one thing here. So let me initialize head to, this one will be new node. We have considered dummy head and tail. This one I'm speaking line number 14. So we have to initialize that one within the LRU cache initialization part, right? So this will be new node of initial one, 0 comma 0. Same goes with the tail as well. So let me copy paste the same thing here. Instead of head, let me make this one tail. This remains same, new node of 0 comma 0. Now head dot next has to be equal to tail initially dot next has to be tail, and tail dot previous has to be quite obviously head, quite obviously head, right? So this is fine. We are done with the initialization part. Next, let's move on with the get method. Let's move on with the get method. So here within the get, what we'll do, if we know this, the return value of the get method is this one, what do we call, integer, right? So if we cannot get the key, I mean if we cannot get the value based on the key, then we have to return -1. This was given in the question itself. This is given in the question itself, right? This is the base case. Let's write this one in the form of code, right? Let's articulate the same thing in the form of code, whatever we discussed in the approach. So this will be map dot contains key of key. Then what we will do, then we have to return -1. Then we have to return -1. So let me assign node this one to map dot get of key, map dot get of key. This is fine. The next step is we have to remove from current position. We have to remove the node from current position. So I'll just make use of remove of node, remove operation. I have just made use of the remove operation, right? So also we have to move to the front, nothing but the MRU, right? Most recently used, we have to move to front. For that, let's make use of the insert to head. Insert to head. So just give me a second. Yeah, insert to head of node. This is fine. Finally, let's return the value of the node. Finally, we have to return the value, right? So this is of the type I mean the return value is integer, so we have to return the value of the node. Here in this case, this will be node dot value, node dot value, right? So this is fine. Now let's move on with the put method. Now let's move on with the put method. So we have one more method or what? So here I have made use of the remove and this one, right? Insert to head. So this one, these are the helper functions actually. Oh, I didn't write the helper functions at all, man. So let's do one thing. Just give me a second here. Mm, yeah, let's do one thing. Let's write the helper functions first. So to make use of this one remove and insert, insert to head of node, whatever we have written here, we have to write the helper functions, right? So we haven't written the helper function at all. So after writing the helper function, I would have made use of these things here. Sorry, I have written this one first itself. Don't get confused here. Now let's write the helper function first. Let's go with the remove. So I'll just go with the remove method here. Private void remove this one node. This will be node. This is fine. Node. So within this method, so let's remove from the map. So this will be map dot remove node dot key. This is fine. So the next step would be we have to unlink from the list, meaning node dot prep dot next will be node dot next. This is fine, right? So the next part is we have to go with node dot next dot prep, but this one we have to assign this one. We are removing, right? So we have to assign this one to previous. So this will be node dot previous. So this is fine. We are done with the this one remove. Done with the remove method. Also we have to go with the insert to head. So I'll just go with private. So this will be void and insert to head. Insert to head. So this one will be node. This is fine. So within the insert to head method, first we have to add this one to the map. First we have to add to the map. So I'll just make use of the put operation that the map provides. So what we have to add? Key. So this will be node dot key and this one node. So this is fine. So the next part is we have to insert right after the head. We have to insert right after the head. So this I can write it in this way. Node dot next. Let's assign this one to the head dot next. Head dot next. This is fine. Next, let's assign the node dot previous to head. Node dot previous to head. This is fine. The fourth step is here we have to assign previous to node and next to node. We have to assign previous to node and next to node. So here this will be head dot next dot previous. Let's assign this one to node and also next. So next I'll just go with head dot next equals node. This one. This is fine. We are done with the helper functions now. We are done with the helper functions. We have already made use of the insert to head and remove methods within the within the get method, right? So we are done with the get method entirely, right? So now as we are done with the this one get method entirely, let's move on with the this one put method, right? So put, what we have to do in the put, basically put consists of the return value null. Basically there is no return value. We just have to insert the element by making use of the put. Any put you can consider, this one first put. So we have to insert the element into the hash map, right? So we have to insert the element into the hash map by making use of the put operation. By making use of the within the put, sorry, within the put we have to insert the elements or update the value by making use of the, I mean update the value based on the key. Update the value based on the key, right? So this is what we need to do in the put. There is no return value. There is no return value, or return value is always null. So let's go with the first step here. So we have to remove the old node, right? So we have to remove the old node if the capacity exists. So here in this case we can write in this way: map dot contains key. Let's pass the key as parameter. If it consists of the key, then we have to remove the old node, meaning, so let's go with the remove. We have to get the value, so I'll be making use of the get operation here, get of key. This is fine. So we are just removing the old node here. The next part is if map dot size here, this is equals to capacity. If map dot size equals to capacity, so then we will remove the LRU. We will remove the LRU, nothing but the least recently used, just before the tail. Just before the tail we'll be making we'll be removing the LRU, least recently used, right? So here in this case I'll just go with remove of tail dot previous. So this is fine, easy, right? So we are done with this part as well. Two conditions, removing the old node and also removing based on the LRU. This is fine. The final one is we have to insert the new node at the head, right? After removing the LRU, we need to insert the new node at the head. So I can just write in this way: node, new node this one equals new node of key comma value. This is fine. Key comma value. The final step is here. We have to insert the new node at the head. Nothing but insert to head of, let's pass the new node, right? So we are done with the this one put method as well. So there is no return value for this. We just have to insert or update. So we are done with the mainly two conditions, right? Here, this one final step is we have to insert the new node at the head, right? So this is fine. We have to evict the least recently used, and then we have to insert the new node. That's what we have to do. Or we have to add uh, the value. So that's what we'll be doing in the this one put method. So we are successful in that. We are done with the put method. So now we are done with the entire code. So let me format the code once and let me hit the run button. I hope this works, man. Let's see. So here you can clearly see the sample test case is getting accepted, right? So here let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case. The code works absolutely correct in this case, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.